So it turns out this quantity, sum of squares within, relates to the pooled sample variance, which we saw when we were doing pooled t-tests. Okay. So SP squared, the pooled sample variance, was calculated by taking each value, subtracting the mean in its own group, squaring those differences, adding them up, and dividing by n-2 in the context of a t-test. Right? Again, in the context of the pooled t-test, we calculate the pooled sample variance by taking each data point, seeing how far it was from the mean in its own group, square those, add them up, divide by n-2. So this numerator, this thing we're now calling SSW, is exactly what I just described. Take each data point, subtract the mean in its own group, square them, add them up. The denominator now, instead of writing n-2, I'm going to write n-I, where I is equal to the number of groups. The way we, this is the word group, we'll try again. The way we justified dividing by n-2 in the t-test case was, I said that we've used up two pieces of information before we get to estimating this variance, because we had to estimate the mean in each group. So here, if we have I groups, then there are I means that have to be estimated before I can calculate this quantity. So a generalization of the pooled sample variance that you saw in the t-test context is this one, where you divide by n minus number of groups. And of course, this implies that SSW can be rewritten as n-I times SP squared. Okay, and again, our learning goal is to be able to orient yourself and compare these quantities to each other and identify these quantities in output, and understand how they relate to each other. So a focus of this lecture is this equation and the one that we looked at for SST as well, that relate these sum of square quantities to other quantities that you've seen before.